Today's lesson is over quadratic roots, and quadratic roots are the points at which the parabola intersects the x-axis. Quadratic roots are also called zeros, solutions, and x-intercepts. We can actually look at a quadratic when it's graphed and tell what the quadratic roots are just by the way the graph looks. If the graph crosses the x-axis at 2 points, then there's going to be 2 solutions. If it touches the graph once, like that example, there will be 1 solution. And if the parabola doesn't touch the x-axis at all, there's no solution. So most of our lesson on quadratic roots is graphing. So first thing we're going to do on number 1, y equals x squared plus 4x minus 5, is we're going to identify our a and our b. So a is 1, because that's the number in front of x squared. B is 4. So first thing we've got to do is we've got to find the axis of symmetry. So x equals, we will have negative 4 on the top and 2 times 1 on the bottom, which gives us negative 2. So this is our axis of symmetry. Okay, then we're going to plug negative 2 in for our x's to find our y. So y equals, we're going to have negative 2 squared plus 4 times negative 2 minus 5. And so y equals negative 9. So the vertex is negative 2, negative 9. Now, we put that in our table in the middle, just like we did on our graphing lesson. And we're going to go, this time we're going to go 3 below and 3 above. So negative 3, negative 4, negative 5, and negative 1, 0, and positive 1. Now, remember, to find your y values, you take each x value and you plug it into your original formula equation and solve for y. So when I plug in negative 5, I get 0. When I plug in negative 4, I get negative 5 for the y. When I plug in negative 3, I get negative 8 for the y. When I plug in negative 1, I get negative 8. When I plug in 0, I get negative 5. And when I plug in 1, I get 0. So now we're going to graph these. And so that's what our parabola looks like for number 1. Now, right here, where the parabola is crossing x-axis, those are our solutions. And we use whatever the x value is. So that is at negative 5, and this one is at positive 1. So x equals, we do our curly brackets, negative 5, positive 1. We use curly brackets because we don't want it to look like an ordered pair, because it's not an ordered pair, it's just 2 solutions. So that is how you find the solutions to a quadratic equation, by graphing. Now the next thing we're going to look at, I'm only going to do one of those, is the discriminant. The discriminant is used to determine the number of solutions. So let's say we have a quadratic equation and we don't want to graph it, but we want to know, well, how many solutions does it have? So we're going to find what's called the discriminant, and we use a formula, D equals B squared minus 4 times A times C. If D is greater than 0, then there are 2 solutions. If D is equal to 0, there is 1 solution. And if D is less than 0, there are 0 solutions. So let's look at number 7. First, we're going to identify A, B, and C. A and B you're familiar with. We've been doing that. A is 1, B is 5. C is always this number here at the end, 4. And then all we're going to do is substitute those into our formula. So D equals, we're going to have 5 squared minus 4 times 1 times 4. And when we solve that, we get 9. So D is equal to 9. Well, 9 is greater than 0, so that means there's going to be 2 solutions. And let's look at number 12. Y equals negative 3x squared plus 5x minus 8. A is negative 3. B is 5. C is negative 8. D equals 5 squared minus 4 times negative 3 times negative 8. So once I solve that, I get negative 71. Well, negative 71 is less than 0 because it's a negative number. So that means there's going to be 0 solutions. And that is how you find the discriminant.